You've got a science demo and you've nailed it at home. You try it in front of all your pupils in the classroom. What do you get? Silence. Or worse, the class goes wild. And then when you look at the worksheets, you think, who on earth were they paying attention to? Now, that's not on you, and it's not on the kids. The problem? It's the connection. You basically lit the spark, but there was nowhere in the child's brain for it to land. And the fix is a simple process that you'll remember on a wet Tuesday morning at 9:02 a.m. And wait, this isn't more prep. This is the 10% that's gonna make the 90% of efforts that you're already putting in just glue together. And it's simple. Spark them with curiosity. Build on this with action and reflect to lock everything in. So where does this spark, build, and reflect come from? Well, there's a classic study that absolutely nailed this, and you might have heard it before. The researchers gave kids a passage about baseball. Now, there were some good readers, there were some bad readers. There was a mixed ability, right? But here's the twist. The poor readers that knew about baseball beat the good ones that didn't. I mean, what? That doesn't even make sense. I mean, this seems quite bizarre, right? If you're a good reader, you're a good reader, full stop. No, the context matters. They had the wiring in their brain already. So when they read when a shortstop throws to a first, I can't even remember this. Their brains are running a replay, not trying to decode what all those words are. I mean, what's a shortstop? Now, the same thing is happening when you introduce a new topic. For those of you who know baseball, it means perfect sense. You could picture it in your mind. But for a lot of us who don't, especially myself, I don't know what a shortstop is. I could figure it out, but that's gonna take time. And by the time I carry on reading the passage, there's gonna be more and more things I'm trying to figure out. Now, just imagine that in real time in the classroom. The exact same thing happens when you introduce a new topic. You think of it like spring cleaning. You've got some random items. You've got a big highlighter. You've got some tape. You've got scissors and a Connect piece. The reason they've ended up in this box is because I don't want to throw this stuff away, but there's nowhere proper to put them right now. The same thing is happening in children's heads. Without a mental shelf to put that knowledge on, it gets dumped or jammed in the wrong place. But once you've built that shelf, the knowledge can start to stack up. So, how do we do this? Okay, first is the spark. Here, you give no new knowledge. You prime the children with their existing knowledge. Use words they already know. All you're doing here is clearing mental space, priming curiosity, not dumping information. So this means asking stuff they already know about. They can find that space in their brain and start putting things where they should be. So you can tell the kids, boys and girls, today we're going to be doing an experiment on dirty water. No, I've mentioned nothing about filtration or bacteria just yet. Just dirty water. All of them know what dirty water is. Okay guys, how do we know when a room is hot? Again, I'm not mentioning a thermometer, I'm not mentioning temperature, just hot. They know what hot is, right? Okay guys, what's the difference between a stone and a spider? Again, mentioning nothing about living things or organisms. Keep it simple. Just prime that curiosity, find that mental space in their brain. Spark is about getting them switched on, giving their brains somewhere to put all the knowledge that's about to come. The next step is building, and now we start layering. Now, I always start with a demo, even if it's something silly, because it gives their brain something different to hold on to. Plus, it's another touch point, which I'll get into in another video. Here, we could explain what a shortstop is. Just the one word. Just the one word. You've explained that we're talking about baseball. Now we're gonna go to a shortstop. And slowly, the kids start understanding what you're actually talking about. And we keep building another demo, a big demo, teamwork, worksheets, talking out loud. There's loads of different things you can do here, but here you start to build on that knowledge. Now, what you do in this section is entirely up to you. This is what you're good at, but keep the logic. Start really shallow and slowly build. Each round adds meaning, not noise. And the last step is reflection. This solidifies all their learning. And every teacher's got their own little way of doing this. And for me, coming from an engineering background, I love to relate this to the real world. I would ask the kids, where does this information matter? How could you use this later today? Who would find this information really important? For me, it's always about the connection, getting them to think about this outside of the classroom. Because if that child is talking about these things at their home, you're basically doing work whilst you've got your feet up. So, spark, build, and reflect. Spark finds and clears this shell. Build fills it with information. Reflect locks everything in. Get the rhythm right, and every workshop, no matter how messy or chaotic, will stick. So of course, this video is not complete without an example. Let's take temperature. So let's start with spark. We're not gonna mention temperature, we're not gonna mention thermometers, 100 degrees Celsius, Fahrenheit, none of that. We're gonna ask them one question. Guys, what do we do when a room gets a bit hot? What do we do? And you start looking for those answers. Oh, so we take off our jackets. Miss, we take our jumpers off. Perfect. You're finding that part of the brain that's all about temperature, heat, but they just don't know these terms yet. Then I'll give them a little bit more. Okay guys, it's a hot summer's day. Do you want a warm hot chocolate? Or would you like a really, really cold milkshake, okay? They laugh, they get it, they're primed, they understand these terms, they've heard them around. Hot, cold, summer, they know what these terms mean, okay? No numbers, no instruments, no circuit tricks yet. Just priming the brain, just finding that shelf that's all about temperature. They just don't know the word temperature yet. Now you've got two options. You can go straight to the word temperature, or you can go to Fahrenheit and Celsius. For me, I would point straight at the air conditioning panel. Say, guys, what does it say over there? It says 23C, so that measures how hot or cold this room is, okay? And this room says it's 23C. In the summer, would we expect this to go higher or lower? Oh, guys, we would expect. And the kids know. The kids know, oh, sir, would you expect to go higher? What about in the winter? Would this go down? Yeah, of course, sir, of course it's gonna go down. What about in the summer with the air conditioning on? Yeah, that's gonna go down as well. The kids are starting to think, we've just mentioned, the only thing we've mentioned at this point is Celsius and Fahrenheit. Now we can introduce something called temperature. Okay, so the way to measure this is something called temperature. And there's a scale, and you might have it on the board, and you've got different kind of bits. Then, 0 degrees is for freezing, 100 for boiling, and you slowly start to build it. And now, once you bring out the thermometer, once you bring out the ice, once you bring out the water, the kids genuinely understand exactly what you're trying to explain them. Not just, oh, the bubble's going all the way up to the top when it's 100 degrees. It's just turned from a circus trick to some very serious science. You can carry on with worksheets, you can do classroom demos, you can give the kids the thermometers, whatever works for you. This is all part of building, this is your arena, but start shallow, build slowly. So we want to make sure they use this at home. So get them to think, when you go home today, see what the weather report says about the temperature tomorrow. Or maybe they're cooking that evening. Find out the temperature. Or maybe even they get in the car on the way home. What does the temperature say the outside is? Who needs to understand temperature really well? All of a sudden, we're talking about the application. We're talking about chefs. We're talking about doctors. In one lesson, you've just taken, let's take our jackets off because it's too hot, to a doctor needs to know the temperature of their patients. That's huge. And I'll even push it a bit further. Okay guys, so if it's 45 degrees outside, which we know is quite hot, what would happen to, well firstly, what happens to us? Do we like it? What would happen to the animals? And if I really wanted to, I could link this to global warming. They know exactly what temperature is. I've got them. So you can see what's happening here. It's not about front loading a wall of vocabulary. Sure, the vocab matters, but not at the start. If you dump every keyword before it's worth caring about, it's just white noise. It's the same reason I don't open with demos, because at the beginning, they're just circus tricks. I'll get an applause, I'll get smiles, they'll all be quiet. But a week later, Sir did that thing, remember? With the bubble, and no terms, no definition, they didn't even know what it's called. Just Sir did a trick with the thing and the bubble. I've had it before, I've experienced this, they don't know. I mean, ask yourself, can you remember the last 20 YouTube shorts or TikToks that you watch? The same things happen with our kids. And listen, you can bolt on so many different things, big demos, mini demos, teamwork, worksheets, all sorts. But just remember the steps. Spark, build, reflect. So the next time your demo flops and the kids don't retain a thing, start simple. Don't chase more flash, chase connection. Start really simple. Build the wiring first, find that mental shelf, then start working. They will walk out remembering the science, not just the show. Hey guys, I'm Prem, and I've run over 1,000 STEM workshops and made nearly every mistake there is. Now I'm here to help you teach your students a little better every day.